Hello, welcome to this session on Microsoft Virtual Academy for best practices in planning hybrid cloud solutions. My name is Keith Mayer. I'm a senior technical evangelist at Microsoft for private cloud, public cloud, and hybrid cloud solutions that leverage Windows Server 2012 R2, Hyper-V, Windows Azure Infrastructure Services, and Microsoft System Center 2012 R2. After viewing this session, you can also find me online on my blog at keithmayer.com. Now, throughout the sessions that are part of this hybrid cloud series, we've been discussing Microsoft's Cloud OS hybrid solution. As a hybrid solution, we're all about providing choices to IT pros. Choices that allow IT pros to select the most appropriate way to handle application workload needs today, and choices that also allow you to easily move application workloads to new clouds down the road when new business requirements arise. Our hybrid cloud solution provides the ability to define and leverage private clouds in your existing on-premises data center side by side with public cloud platforms such as the Windows Azure cloud platform as an extension of your on-premises data center when additional capacity and scale is needed on demand to support application workloads. In addition, our hybrid cloud solution can also incorporate hosted clouds, clouds that are supported by service providers that are part of our Cloud OS network. Microsoft System Center 2012 R2 provides a unified management tool set across all these clouds, whether they're private or public or hosted clouds, so that you have a consistent experience for provisioning, managing, monitoring, protecting, and automating application workloads across all of the clouds that are part of your hybrid cloud strategy. So in this session, we'll be discussing planning hybrid clouds. We'll be reviewing tools, reference architectures, and additional resources that you can leverage to easily get started and help prepare yourself for a successful hybrid cloud rollout. Let's get started with assessing what we already have today in our environments. Assessing our current environment is a helpful part of the planning for many large IT initiatives. It certainly applies when we're planning to migrate to a hybrid cloud as well, because it helps prepare a baseline of what we already have today and help determine which applications are well suited to migrating to our clouds and provide initial input into how to approach that migration. To help in assessing cloud readiness for your current environment, Microsoft provides a free tool, the Microsoft Assessment and Planning Tool, or MAP. MAP is an agentless tool. It can be installed and leveraged very quickly because it relies on the current management interfaces for discovering existing computers, performing an inventory, and generating an assessment. The latest version of MAP, MAP version 9, also includes two reports that are helpful when preparing for a hybrid cloud migration: a private cloud consolidation report and a Windows Azure VM readiness report. Let's take a look together at MAP and these reports in our lab. Okay, so here we are in our lab. I've already installed the Microsoft Assessment and Planning Toolkit, and I've brought up the Inventory and Assessment Wizard as one of the first steps in getting started with an assessment of our current environment. The first piece of information that I'm prompted for is to select one or more inventory scenarios. The inventory scenarios allow me to target specific workloads or capabilities within my existing environment that I wish the MAP tool to look at. It can include Windows computers, Linux or Unix computers. It can even include competing virtualization platforms like VMware. From a software standpoint, it can also interrogate not just the operating system configuration, but also the application workloads for select applications such as Active Directory, Exchange, endpoint protection, Link, and SQL Server. It can also interrogate the current configuration of Oracle database servers if you're in the process of planning a migration to SQL Server. And it has a Windows Azure platform migration scenario as well that's really useful when we're looking to assess the readiness of being able to quickly move some VMs up to Windows Azure to take advantage of the capabilities in terms of scale and availability of the Windows Azure Cloud Platform. So I'm going to select the relevant inventory scenarios for my environment, and I'll click the Next button. Because MAP is an agentless tool, it's going to prompt me for which existing management interfaces to use for discovering computers that correspond to any of the inventory scenarios on the prior page. It defaults to using Active Directory, but it can also use standard Windows networking protocols. It can use Config Manager if you have that in your environment. It can scan an IP address range, or you can simply tell the MAP tool manually which computer names or import a file of computer names you wish MAP to be able to scan through. I'm going to select the default of Active Directory. I'll click the Next button, and then I'll specify my Active Directory credentials for allowing the MAP tool to authenticate to Active Directory and identify all of the domain joined computers. I'll click Next again, and I can optionally specify a portion of my Active Directory forest for MAP to focus on for its discovery. It's going to default to finding all computers in all domains, containers, and organizational units, but I could certainly use the second option if I wanted to specify just a subset of my Active Directory forest. I'll go ahead and click Next. Now for each of the inventory scenarios around Windows, around Windows Azure, around SQL and whatnot, MAP is also going to ask me for computer credentials. The computer credentials allow MAP to authenticate to those computer management interfaces with administrative access so that it has the ability to collect inventory statistics as well as performance statistics. Once I've entered in each of my credentials, I'll click Next. And if I have multiple credentials for each inventory technology, I can even order those credentials appropriately for the most commonly used credentials throughout my environment. So if I have a complex Active Directory environment, for instance, where I'm not using a consistent set of credentials across all computers, I have the flexibility to specify multiple credentials and then specify the order in which MAP tries those credentials to authenticate to each computer. I'll go ahead and click Next. I'll get a summary of what MAP is going to do for me. Now the inventory process can take a little while because it does have to connect to each computer, bring in its current inventory information and performance information, but it's a pretty thorough process considering that no agents are used for that collection. Once the inventory process completes, I then have the ability to run one or more analysis reports against that inventory data. And I've got a couple of the analysis reports that we mentioned a few moments ago already opened up with some pre-existing data in them to give you an idea of what those reports look like. And so the first report that I'll bring up is the Microsoft Private Cloud Fast Track Consolidation Report. This is a really useful analysis report that MAP can generate based on the inventory data that it has accumulated to give us a view into recommendations for consolidating the set of machines we collected inventory into onto a set of virtualization hosts, either with a base configuration or with a maximum configuration that we can specify thresholds around, so that we have an initial view into how well we can consolidate virtual machines across our private cloud before we've actually begun implementing our private cloud. So a real useful report from that standpoint. Now, the other report that's really useful for hybrid cloud planning that MAP can also generate is in a Windows Azure virtual machine sizing results report, where it takes that same input of the inventory of our current virtual or physical machines in our environment. It looks at their utilization and configuration and then provides recommendations around Windows Azure machine size, VM size that could be configured on Windows Azure, as well as estimates of compute usage, network usage, memory utilization, and whatnot that would factor in to helping us plan out which of the virtual machines in our environment are going to be most cost effective in moving up to a Windows Azure public cloud model. So another really useful report. Now, in addition to assessing our current workloads in our environment for cloud readiness, geographic diversity is also a strong consideration for many organizations. And Windows Azure has a tremendous amount of flexibility in this area through the Windows Azure Global Footprint. You see, Windows Azure, as a public cloud infrastructure, allows even single site organizations to take advantage of our Windows Azure data centers. We've got 4 data centers within the United States today running Windows Azure infrastructure services. We've got 2 in Europe, and we've also got 2 in Asia. Each of these data centers are located more than 400 miles apart to meet the disaster recovery distance requirements that many organizations have in place. And it allows organizations that today may only have a single data center location or perhaps a few to be able to leverage the global scale of Windows Azure to support both a worldwide audience as well as provide some built-in disaster recovery protection. If you're interested in seeing more details about our global footprint today, you'll find the link down at the bottom of the slide, a handy resource for you after today's session. In addition to our current Windows Azure data centers in these 8 data center regions, we also have plans over the next year for bringing online 2 additional data centers in Australia, 2 additional data centers in mainland China, and 2 additional data centers in Japan as well. And then on top of those infrastructure services data centers, we also have a set of approximately 20 additional data center locations that are used for caching frequently accessed content worldwide throughout our Windows Azure content delivery network. As we look to scale these Windows Azure data centers, certainly physical scalability becomes an issue, and our data center team has gone through several generations of data center designs to come to the point of having a very modular approach to growing the size and capacity of our data centers. Now today our Windows Azure data centers are anywhere between 30,000 and 100,000 physical hosts, give or take a few thousand, and the approach that we use going forward for expanding our data centers is an IT pack approach, an approach that uses pre-assembled components that allows us to very quickly bring online new racks of data center resources in these pre-assembled units. If you have interest in learning more about how we build and expand our Azure data centers, there's 2 links that I've provided at the bottom of the slide that discuss both our IT pack modular approach as well as our Generation 4 cloud data center approach that's been put together by our Windows Azure data center team. All told, this approach and our current data center footprint in Windows Azure allows us to reach 89 countries and territories worldwide for providing cloud services. If you have a need to scale public cloud applications as part of your hybrid strategy, public cloud resources beyond either these 89 countries and territories, or if you have particular requirements that may require you to use a local partner in some of these countries where we perhaps don't have a local data center footprint today, that's where our Cloud OS network of service provider partners comes in place. Our Cloud OS network partners leverage Windows Server 2012 R2 and Microsoft System Center 2012 R2 along with our freely available Windows Azure Pack that essentially allows them to provide a private label version of Windows Azure where they can provide their resources to customers in particular countries where there's very specific needs they may have in terms of regulatory or compliance or in-country needs or particular location-based needs for locations that are outside of our current list of 89 countries and territories. So I'd encourage you to check out our Cloud OS network partners as part of your evaluation process, particularly if you have very large global needs as you're scaling your hybrid cloud. As you're thinking about Windows Azure and other public clouds that are part of your hybrid cloud strategy, planning for costs is also a key factor for most organizations. And to make it really easy to plan for Windows Azure cloud costs, you can take the map output that we saw as part of the Windows Azure VM readiness assessment and plug that data into our Windows Azure pricing calculator. The pricing calculator is available on windowsazure.com. It's very granular. It allows you to plan out varying sizes of virtual machines running either Windows or Linux workloads. It allows you to plan out your storage costs. It allows you to plan out your network bandwidth costs. So it becomes very easy to take the data that map outputs, plug it into a calculator, and be able to come up with a rough order of magnitude cost for moving forward with placing some of your workloads on Windows Azure, freeing up your on-premises data center resources then for your more mission critical resources that really have a need to run in your on-premises data center. As you're comparing public cloud platforms as part of your hybrid cloud strategy, you may also be very interested in researching the report that was done by an independent cloud analyst firm, Cloud Spectator. Back in June of this year, Cloud Spectator spent a week analyzing the cost and performance of 5 major cloud providers: Windows Azure, Amazon EC2, HP Cloud, Rackspace, and SoftLayer. They ran the same general workloads across all of these cloud providers and used an industry standard Unix benchmarking tool to test and drive the performance of each of those workloads across each of those clouds. The results that are available at their site, at Cloud Spectator's site in their full report, were quite interesting. I've got a few of the results summarized. What they found in terms of Windows Azure is that Windows Azure they found to score 3 times higher than Amazon EC2 did on average from a performance standpoint. And in terms of Rackspace, they found that because of Windows Azure's lower cost, that it provided 5 times more value than Rackspace did in their testing on average. So some really good information on comparing these various cloud platforms from Windows Azure to these other clouds. You can find the full details at Cloud Spectator's site in their full study. Now certainly analyzing the cost of a hybrid cloud solution is much more than just the cost for running resources on that cloud. It's also more of a total cost of ownership analysis that includes ongoing operating costs and other management costs as well. In addition to our pricing calculator, our data center team also has produced a total cost of ownership, or TCO, analysis tool that you may also find useful during your planning stages. The TCO analysis tool allows you to put in the inputs that relate to your current environment and your plans. So whether you're currently leveraging Microsoft or competing virtualization technologies, you can select the virtualization stack. You can select if you're looking to add new virtual machines into that environment or migrate existing virtual machines. You can specify whether you want it to focus on strictly a private cloud implementation or if you're interested in a hybrid cloud deployment as well, where you'll be leveraging public cloud platforms alongside of your on-premises private clouds. And you can put in details pertaining to how many virtual machines, what percentage would run on premises versus in a public cloud, and general parameters around the salaries of IT management teams within your organization at a general level, so that it can produce an analysis of the total cost of ownership for our solution in the hybrid cloud space versus competing solutions. So it's a great tool. You can access it for free using datacentertcotool.com. So we've talked a bit about geographic diversity, assessing our current environment, planning from a cost standpoint. Compliance, when we're talking about the hybrid cloud or the public cloud, also becomes an area of concern, and our Windows Azure team has been deeply working with several organizations to help address compliance requirements for many common organizations and industries. We currently support compliance around the ISO IEC 27001 2005 standard, SOC1 Type 2, SOC2 Type 2, the Cloud Security Alliance standards, FedRAMP, and HIPAA. And you can find the full details around our compliance across each of these areas out at the link listed on the slide in our windowsazure.com Trust Center page. And then from compliance, the other concern that comes up is availability and service level agreements when we're dealing with hybrid and public clouds. Service level agreements are something that is part of your planning process. Regardless of which public cloud platforms you're looking at, you'll definitely want to dive into the details, spend some time understanding the unique ways that each public cloud provider measures service levels and sets their availability guarantees. We have, from a Windows Azure perspective, a very strong SLA. We provide a 99.95% monthly service level agreement for virtual machines that are configured appropriately on Windows Azure in an availability set. That translates to about 4.5 hours of downtime per year. So it's a very strong uptime measurement. Now, you may have already looked at some of the other service level agreements from other cloud providers, and you may have noticed that many of them also have quoted 99.95% availability. However, again, dive into the details. You'll find that many of those other cloud providers are actually measuring their SLA on an annual basis instead of a monthly basis, which permits them a much longer continuous downtime window when they do have issues. We measure ours on a monthly basis to have much better seasonality of how our service level agreements perform against realistic application workloads that you have running on Windows Azure. You'll also find that many service level agreements are from competing platforms are written to exclude interesting scenarios like bugs or antivirus problems, malware, security attacks, hardware outages in their data center. We have an SLA that basically attempts to include everything that's within our control, from data center hardware failure to data center network or power failures. Hardware upgrades, software maintenance, planned maintenance are also included in our SLA. A lot of other competing SLAs don't include that. The items that aren't included are basically the items that are outside the control of our Windows Azure team. So items that affect guest operating system and applications, patching and updates and whatnot. Those are all taken care of by IT pros as the customers that are running those applications on Windows Azure, as well as connectivity that's outside the perimeter of our Windows Azure data centers, either customer network failures or intermediary internet provider failures or internet backbone failures. So those are not included because they're outside of the control of our Windows Azure team. You can find the full details of our service level agreements out on windowsazure.com, and I definitely, again, as part of the planning process, encourage you to download those SLA documents and have someone on your team go through them very carefully in comparison to any other public cloud providers that you may be evaluating, to make sure that you can do a good comparison of what we're guaranteeing versus what many of those other cloud providers are guaranteeing. In addition to availability, portability is another consideration that I see many customers looking at, because in today's age, even though we may be running certain applications in one public cloud versus another or on premises, there's no guarantees down the road that our business requirements won't change, and we may be finding ourselves needing to move those virtual machines to a new location, a new hosted cloud, back on premises, or up to Windows Azure, for instance, based on changing application needs. With our hybrid cloud solution, if you're running Windows Server 2012 or 2012 R2 Hyper-V as your virtualization layer on premises, you'll find that Windows Azure supports a compatible virtualization layer up in the Azure cloud, compatible with Hyper-V on premises, allowing you to have on-premises workloads that are already virtualized as virtual hard disks be easily transported up to Windows Azure or back, or easily transported to hosting cloud providers that are part of our Cloud OS network and back, giving you the choices to be able to easily move those workloads back and forth between your location and other public or hosted cloud locations at will, to address any of those changing business requirements. Now, if you're using a different virtualization platform, either in your private cloud or in your public cloud, you may find the links that are listed at the bottom of this slide to be handy. I've got two step-by-step guided labs that you may be interested in. One that walks through migrating cloud-based VMs that are running on the Amazon AWS cloud over to Windows Azure, and one that targets VMware VMs that are running in an existing private cloud environment, an on-premises data center, using VMware as the virtualization layer, migrating them over to a virtual hard disk that can be moved either to Hyper-V on premises or to Windows Azure or a hosted cloud provider that is using Hyper-V as well. So some great additional resources for being able to move to a standpoint where you have portability of your virtual machines across private clouds, public clouds, and hosted clouds. And then finally, as part of our initial planning criteria, hybrid cross-premises networking also oftentimes comes into play, where you may have an existing on-premises private cloud of resources, and rather than only running public-facing, web internet-facing applications up on your public cloud platform like Windows Azure, you may want to leverage the resources that are part of Windows Azure, part of that public cloud platform in our global data centers. You may want to leverage those resources as really an extension, a secure extension of your on-premises network. And that's where Windows Azure provides virtual networking. So I would definitely make sure as part of your planning that you check out the site-to-site virtual networking capabilities of Windows Azure, as well as any other cloud platforms that you're evaluating. Windows Azure's virtual networking allows us to define up in the Windows Azure cloud an isolated virtual network that has one or more subnets used to organize our cloud-based VMs that are running on the Windows Azure platform. That isolated virtual network makes sure that all of the virtual machines that are part of that virtual network are partitioned off from any other virtual networks running in your Windows Azure subscription or other customers' Windows Azure subscriptions. So it's a secure isolation layer. In addition, Windows Azure Virtual Networks also include built-in support for VPN gateways, so that you can establish site-to-site IPsec VPN tunnels back to your on-premises environment, and at that point be able to route out to Windows Azure as though it's another data center location on your wide area network. Once that site-to-site IPsec VPN tunnel is up in place, all of your on-premises workloads will view that new subnet, the new set of subnets up in your Windows Azure virtual network as simply another branch location, another data center location on your wide area network. If you're interested in learning more about Windows Azure site-to-site cross-premises networking, at the bottom of the slide I have a link to a guided lab that you'll find very helpful in better understanding the process for building secure site-to-site cross-premises connectivity to Windows Azure and leveraging that as part of your hybrid application workloads that you're running between your on-premises private cloud and public clouds that are running on the Windows Azure platform. So be sure to check out that VNet Cloud Lab link as part of your planning process to learn more about cross-premises networking. Now, we also talked about management tools. And System Center 2012 R2 is our management tool set that provides the ability to create and manage private clouds as well as hybrid clouds that consist of private, public, or hosted clouds. System Center 2012 R2 includes several components. And the component that we use for taking our on-premises data center and creating private clouds around it is the Virtual Machine Manager component that's included with System Center 2012 R2. Virtual Machine Manager allows us to create one or more private clouds using the Create Cloud button. Those private clouds are used to pool together our virtualization hosts that could be running Hyper-V, VMware vSphere, or Citrix Xen Server, our logical networks, our storage. All of that can be pooled together into one or more private clouds, where we then have capacity limits that are set on each of those private clouds, effectively having each private cloud be a virtualized representation of our data center across these various resources. Once we have those private clouds set up, we can then assign access to those private clouds, so that if we had development teams or business unit IT teams that were interested in having direct access to be able to provision resources on these delegated private clouds, we could assign them access through a user role, scope that down to just the clouds within our private network, our private data center that we wish them to have access to, further restrict quotas, and even go down as far as restricting actions of what they can do on those private clouds, so that as a developer, perhaps they can only provision a new virtual machine from in a permitted template that we've already preset up for them, and then once those virtual machines are provisioned, have very limited management control based on their needs as a developer around those virtual machines. So System Center 2012 R2 Virtual Machine Manager allows us to build those private clouds, and then for monitoring our clouds we have System Center Operations Manager. System Center Operations Manager has a specific management pack for Windows Azure, as well as a management pack for Hyper-V virtualization hosts. What that allows us to do is have a consistent view both at a fabric level for our virtualization fabric, as well as having the ability to have System Center Operations Manager leverage agents within each of the virtual machines that it can query and use to track at an application workload and operating system level very granular statistics on the operation of those virtual machines. So we can look at the fabric and we can look inside the virtual machines to get a total 360-degree view of our hybrid clouds and the workloads that are running on top of them. From a management perspective, when we start moving into that hybrid cloud space, System Center 2012 R2 also includes App Controller as an additional component. App Controller allows us to integrate our on-premises private clouds. Again, those would be private clouds that Virtual Machine Manager built using Hyper-V, VMware, or Citrix Xen Server virtualization hosts as resource pools. It can integrate those on-premises private clouds with our public cloud Windows Azure infrastructure or our hosting providers, our service providers' hosted clouds. It allows us to have App Controller as a single consistent web-based interface for allowing the management of virtual machines across our hybrid clouds, effectively extending our data center to include not just the virtual machines that are running within our data center, but having a consistent interface for managing those virtual machines that are also running on Windows Azure or within hosted cloud environments. So why don't we drop over into our lab again and take a look at System Center 2012 R2 App Controller and how it can allow us to manage hybrid cloud infrastructure. Okay, so here we are in our lab, and we're looking at System Center 2012 R2 App Controller. You'll see on its overview page that we've got the ability to connect to private clouds, one or more, through our virtual machine manager server connections, public clouds, as well as hosted clouds through a service provider connection. And I've currently got one virtual machine manager server added, as well as one Windows Azure subscription added in. And what this allows us to do is to begin thinking about our virtual machines regardless, in a consistent manner, regardless of which cloud they're part of. When I go over to virtual machines, for instance, I see a list of all of my virtual machines across all of my clouds. I have consistent ways of interacting with those virtual machines for performing basic management. And when I go to deploy a new virtual machine, I have one web-based interface for being able to deploy across all of my clouds, whether they're private clouds, whether they're public clouds, whether they're hosted clouds, and step through the process of being able to configure with a consistent tool and a consistent approach virtual machines across any of those clouds. In addition, in App Controller on my library page, I also have the ability to plug in on-premises shared folders and see all of my storage locations that are part of my public cloud or hosted cloud. So when it comes time to actually move virtual machines from a public cloud location to a private cloud location or vice versa, with App Controller, that process of moving virtual hard disks and virtual machines back and forth between clouds becomes as simple as a select and copy-paste operation, where I can select one or more virtual hard disks that I wish to copy down to my on-premises private cloud, select copy, move over to one of my on-premises shared locations, right-click, paste, and have App Controller manage the entire end-to-end process of copying that data from public cloud to private cloud to public cloud, or to a hosted cloud location, all from within App Controller in System Center 2012 R2. So what we've just looked at is the management side of being able to properly manage a hybrid cloud that consists of private, public, and hosted cloud resources from a consistent management tooling for provisioning, for managing, for monitoring, for automating, and for protecting, without having to use separate tools and managing each of those cloud locations as separate discrete sets of virtual machines and application workloads. So for continuing forward in the planning process for your hybrid cloud, there's some great resources that we have available to help you plan and build your private and hybrid cloud. We've got a couple free ebooks that are great resources for helping you to get started. There's an Introducing Windows Server 2012 R2 ebook that provides a great technical overview across all of the private cloud foundation features of Server 2012 R2. And there's also another free ebook on hybrid cloud management with System Center 2012 that dives deeper into using App Controller and VMM together as part of your private cloud and hybrid cloud management strategy. And then finally, out at our Build Your Cloud page, we've got a whole series of additional material that allows you to go deeper on planning and building your hybrid and private cloud environment. You can get to that out at the Build Your Cloud link at the bottom of the slide. Some of those resources that you'll find helpful out at that Build Your Cloud page are reference architecture guides that our Building Clouds team or our other data center or product teams have put together. The reference architecture guides are great because whether you're a small, medium, or large organization, it allows you to quickly form a standard reference architecture that's helpful for standardizing the deployment and configuration of a private cloud environment and then attaching that on to a hybrid cloud through public cloud providers like Windows Azure. So there's a few reference architecture guides in particular that you'll find helpful. There's an infrastructure as a service fabric architecture guide for helping to plan the initial provisioning of that private cloud environment. There's an infrastructure as a service fabric management guide for helping to plan out how you're going to manage your private cloud fabric. And then there's also a hybrid cloud infrastructure design considerations guide that steps through in more detail the planning and design considerations of taking that private cloud and extending it to a hybrid cloud by leveraging public and hosted cloud resources. Certainly beyond these great resources, there's also additional resources that are available to you through our TechNet Evaluation Center, where you can download free evaluation versions of our private cloud foundation and management software. You can also sign up for a free trial of Windows Azure so that you can experience Windows Azure directly from a hands-on perspective. In addition, we have TechNet Virtual Labs that allow you to jump in to the middle of a pre-made lab environment virtually without having to spend the time in building your lab environment. So if you want to get more hands-on with just a particular component or aspect of Windows Server 2012 R2, System Center 2012 R2, or Windows Azure, the virtual labs are a great way to be able to do that very quickly and easily. And then feel free to come back for the other modules that are part of this particular series on the Microsoft Virtual Academy, as well as our other series. We've got some great content on Windows Azure, on Windows Server 2012 R2, on System Center 2012 R2, on building private clouds and hybrid clouds that you'll find really useful. So be sure to browse through the other courses that are available on Microsoft Virtual Academy as well. Thanks so much for attending this session today, and certainly feel free to contact me down the road. I hope you find the additional resources that we've made available useful as you continue through your planning process in planning your hybrid cloud. Thanks so much, everybody. Have a great rest of your day.